Okay, boys and girls, let's explain the different hypotheses of what stars are made of, how stars work, etc., and tell my favorite hypothesis and why it's my favorite. Well, like this might be problematic because that's quite a bit hidden in this, etc. It's like many PhD dissertations, many books. Millions of articles. I don't think I can explain this. Uh, but anyway, like different hypotheses. Let's start with this. Well, there's a very simple one which we may call, actually, let me write this down here, gaseous, right? Gaseous hypothesis, which states that the sun is so hot that it cannot possibly be solid or liquid, so it has to be a gas. So it's a gaseous plasma, supposedly again, mostly hydrogen, supposedly again. So inside of it, it's very dense because like the pressure is very high, etc., etc. So thermonuclear fusion happens there. So the energy starts creeping upwards from there. It's firstly emitted in the form of like gamma rays, and then it starts to being absorbed and re-emitted, etc., etc. And when it goes to the surface layer, it's kind of emitted as the visible light, right? Something like this. Then we have like the systems of electric currents inside the sun that creates, the dynamo, so-called in air quotes dynamo effect, which creates the magnetic fields, and that's what produces what we observe more or less in the gaseous model of the sun. It has a lot of problems. I'm not gonna lie, like so many problems I can't even possibly list them here. But this is the model, and this is how stars work in this model. All right. Hopefully this is understandable. Then we have Pierre-Marie Robitaille's liquid model, which states that the sun is probably a liquid metallic phase of hydrogen. So it's also hydrogen, just like in gaseous model, but it's a liquid instead of gas. All right, and it has certain advantages in terms of in comparison to gaseous model. I don't think Robitaille ever touches on the topic of magnetic fields, even though I think this is an essential part of the sun, like how magnetic fields are produced. Well, like how should we modify our dynamo models with respect to gaseous I think he says that in order to sustain the dynamo, you have to have like some sort of framework. So some condensed matter should be present in order for the dynamo flows to flow in, so to speak. So in this sense, maybe you can claim that he addresses this issue, but I'm not sure about this. Ask him again. How stars work in this model? Well, they're just liquids, okay? Like that's the only difference. It leads to certain possibly observational differences, right? Different explanations for the same observables, rather, as in gaseous model. But yeah, that's kind of the difference. Then what do we have? Solid sun models or star models. You probably never heard about them, and there's only one example I'm aware of. There's a guy named Michael Muzina who has been somewhat active on the Thunderbolts project forum some years ago. Like last time I talked to him was maybe 2021, something like this, so it was quite a while ago. But he was much more active before that. So at some point, I'm not sure he still thinks this, but he claimed that the sun is probably like a ball of iron, essentially, like a solid ball of iron, and all the surface activity that we see is due to some, electric currents flowing on its surface and stuff. Like whether you like it or not, like I'm not sure how well developed this model was, and how stars work, as we say here in this model, but at least it's a model. Okay, you can say, well, okay, let's imagine the sun is a solid ball of metal. What happens then? Well, this is a hypothesis. Okay, so you can maybe develop it if you like. Yeah, so these are probably the main ones. And what is my favorite? I'm kind of on the fence, to be honest. Like I don't really enjoy all of these too much. Like this one is kind of interesting because it's like somewhat better than this one, but at the same time it's more developed than this one. So it's kind of like it's something might be found here potentially, but obviously, hundreds of people need to work on its development, and right now it's probably Robitaille and maybe like a dozen enthusiasts. I don't know. So yeah. And there you go. So I don't really have a favorite one. And look, this is such a narrow view, right? So if we're talking about like philosophical terms, like these are different states of matter. Like who says that the sun is made of matter in the first place, you know? Like who says the sun is made of chemical elements? Like it's such a big leap to say that whatever we get in the lab is the same stuff we see in the sky. Like, you know, like speaking very abstractly, very generalizably, how are we so sure that the sun is made of everything that we see around us on Earth, for example? I don't know. Like, you know, the sun may neither be a gas or liquid or solid or even a plasma if you wish. Maybe the sun is not a plasma in the first place. I don't know. Look, we only observe what, like 1,000th of a percent of the solar volume, right? The uppermost layer. Same is true for Earth, by the way, but a little bit better percentage. But the point still stands. We have no idea what 99.99999% of the sun looks and behaves like, right? Because we don't see it, and we have no instruments to interact with it in any way. So this is all like speculation, a pretty wild one, I would say. So out of these three, definitely liquid. Out of the model, the possible hypotheses of the stars and the sun, it's probably neither of these, honestly. Like, you know, Kozyrev had the hypothesis that stars produce energy by some completely other method, that they're kind of absorbing time, and I'm speaking like very abstractly, like philosophically speaking, okay? And you may say it's kind of crazy, it sounds stupid, but think about this. I'm not sure if you're aware of this factoid, but just ruminate on this this evening, okay? So the density of energy that the sun emits per unit of mass of the sun itself is lower than the density of energy that the rotten leaves emit. So it's a very small amount of energy that the sun emits per unit of mass. Like it's very calm and dormant. It's basically kind of cold in this sense, you know. It's like rotten leaves level of cold. And the human body emits like 2 orders of magnitude more than the sun per unit of mass. So if you make a sun out of humans, you know, it would, I don't know, it would burn all the planets. Okay? So there you go. There you go. These are the hypotheses, and I'm kind of, you know, I feel that this is too narrow. I feel that, I don't know, like a complete reevaluation of everything is needed, but then I'm just a rogue philosopher. I'm not really a scientist per se, even though I was one. Okay?